Hello, physics students. This is Mr. Dillick. This is physics video number 6, and it's about uniform circular motion. This is actually a pretty weird topic for us to talk about at this point because we've been talking only about linear motion up to this point. But really, it actually kind of makes sense for us to take a little time out and talk about uniform circular motion because we've just spent quite a bit of time talking about how we measure acceleration. Acceleration is a change in velocity over time. We said it's when something is speeding up or slowing down or changing direction. If any of those things are true, it's considered to be accelerating. And so uniform circular motion is kind of something we want to talk about at this point because it fits a bit of a quirk in our definition of acceleration. So let's get to that first by talking a little bit about why we call this motion uniform in circular motion. Well, uniform means the same or constant or consistent. You can imagine if we were all wearing uniforms, we'd all look, well, the same, or we'd consistently be wearing the same items. So when we talk about uniform circular motion, we're talking about a motion that's clearly circular, and it can be circular in a lot of different directions. It could be something that's spinning, which we could call rotating or revolving, in a plane that is horizontal or one that's vertical or somewhere in between. So don't get caught up too much about how this looks in space. But instead, what I want you to do is just imagine something that is a uniform circular motion. So that means the object isn't changing direction. It's going to keep spinning the same way. But it has to be uniform. So it has to be moving at a constant speed. So if it happens to be spinning at a rate of maybe 2 revolutions per second, well, that can't change. It can't speed up and go a little faster or slow down. It's got to stay the same rate. And so the question that we want to ask is there an acceleration when something's moving at a uniform circular motion? Keep in mind that it's not changing speed. So could it be accelerating? And there's a surprising answer to that. So if you take a look at the picture here, this is the circular motion as viewed from above. So imagine this was you were God and you were looking down on a helicopter, for instance, and the blades were spinning counterclockwise. Or maybe this is me spinning my keys in that are on a lanyard around my head or anything on a rope. So as viewed from above, from a God's eye view, we see that it's going in this counterclockwise rotation. Okay, so what's this yellow dot represent? That's the center of the circle, and that's where the axle of the helicopter propeller would be, or maybe it's where my hand would be if I was spinning my keys around on their lanyard. What's this pink dot? Well, the pink dot would be my keys. It would be, or some point on the edge of that helicopter blade, and they're going to be moving. And this arrow that's pointing this way kind of tells you the linear velocity, the linear direction that object is moving at this particular moment in time. If the keys were spinning and they followed the circle and now they were over here, then that arrow would be pointing to the left. But if it was over here, that arrow would be pointing down. If that arrow was over here, it would be pointing to the right. And when it's back over here, it's pointing up. And so what we can see is that the object's linear velocity is always changing direction. Its linear velocity is always changing direction. So that would be considered an acceleration because, remember, acceleration can be speeding up, slowing down, or changing direction. This has a special name. It's sometimes called centripetal motion. The word centripetal means to move inward toward the center. Centri means center, and to pedal means to literally move your feet, like the pedals on your bike. So to literally move your feet towards the center is what this word centripetal means. Now keep in mind, this physics word, centripetal, means something is constantly pushing or pulling that motion towards the center. Centrifugal is a word that you sometimes hear people use, and it's not really a physics term. I mean, it has a physics meaning. It means to spin outward, but it's not really a physics term. It describes the effect of momentum, which we are going to talk about much later. So if something is spinning in a centripetal motion, even if it's not speeding up or slowing down, can it be considered to be accelerating? The answer is yes, because it's constantly changing direction, and that is due to whatever force is pushing or pulling it constantly towards the center. In the case of my keys, that would be my hand constantly spinning it spinning it around. So my hand is providing this centripetal acceleration. And so that centripetal acceleration is the result of a constant change in direction. Notice, acceleration is a vector. It must have a direction. So the direction of the centripetal acceleration is always towards the center of the circle. Okay? So let's look at that picture again. What we know is that the centripetal acceleration always points towards the center, and then the linear velocity of that object at any point has a special name. It's called the tangential velocity. This word tangent is a math term. It means a line touching a curve at only one point, and that's basically what that line is doing. It's touching it only at this point. So again, if this is my hand and these are my keys and this is the lanyard, the piece of rope, if you will, that's holding my keys connected to my hand, and it's spinning this way counterclockwise as viewed from above, notice the right angle here. The centripetal acceleration is always pointing towards the center, and the tangential velocity is always at a right angle to it. And here's a nice equation that describes that. Centripetal acceleration is based on the tangential velocity and then the radius. How long is this distance between my hand and the keys, or whatever we happen to be spinning? And that's called the radius. So here you can look at an equation, and I've taught you how to read an equation. You can see that centripetal acceleration is directly related to tangential velocity. But we mentioned that when we talked about relationships that we would later talk about the difference between a linear relationship and a nonlinear relationship. So the relationship here is not linear. That is, if you graphed it, you wouldn't get a line. It's exponential. If you graphed it, you'd get a parabola. You'd get a curve. And so acceleration is directly and exponentially related to tangential velocity. But here you can see acceleration is linearly and indirectly related to radius. That is, the smaller that radius gets, the greater that acceleration is going to be in order to produce that tangential velocity. So those are the important relationships that I want you to know. Like any other acceleration, it's measured in meters per second squared, and it just happens to be a special kind of acceleration that has to do with things that are moving in a circular path.